Hello and welcome to Advantech Embedded Talk. I'm Stephen Liu from Taipei, Taiwan. This Embedded Talk series features interviews and talks given by industry experts in and out of Advantech across the globe, with a special focus on key technologies and use cases found in emerging applications. We probe into certain vertical markets such as EV charging, robot, AMR, low-speed autonomous driving, and ruggedized edge computers from an embedded systems perspective, which includes embedded hardware and, of course, software and security. This episode is about the use of inertial measurement unit, or IMU, on AGV, AMR, autonomous driving, and even drones. We are pleased to invite a true expert from Movella, Bryan He. Bryan is Senior Product Specialist of Movella's Automation and Mobility Division. He is based in Shanghai, China. Hi, Bryan. Thank you for joining us.
Hi, everyone. I'm very glad to join this session together with Advantech to share our vision together in the AMR and AGV market.
Thanks, Dan. Before I have Bryan to talk, I'd like to introduce a group of Advantech colleagues around the world. They are dedicated to serving a growing number of AMR robot developers. In fact, Advantech has established a global business development network for this particular vertical market. Now, let's hear what they'd like to know from Bryan.
近年来，我发现许多研发的嵌入式计算机客户都采用了 IMU， 请您帮忙说明不同类型的 IMU 在产品形式、精度与功能上的差异。感谢。
안녕하세요. 저는 어드밴텍 한국지사에서 근무하고 있는 PSM 정인책임이라고 합니다. 먼저 기사가 진행하고 있는 프로젝트와 관련해서 몇 가지 질문사항이 있는데요. 첫 번째로는 IMU가 필요한 로봇 및 AMR에는 어떤 종류가 있는지 문의드리고 싶습니다. 두 번째는 한국을 비롯한 글로벌 성공 사례가 있는지, 그리고 있다면 그 성공 사례에 관해서 공유할 수 있는지 문의드리고 싶습니다. 감사합니다.
Ciao, sono Giovanni Faravelli, Business Development Manager di Advantech Europe per il mercato della robotica AMR e AGV. Penso che nessun sensore sia perfetto. In che modo l'IMU funziona con altri tipi di sensori al fine di fornire una localizzazione più precisa?
Thank you, gentlemen around the world. So, they've got wonderful questions. The first is about the terminology, the term between positioning and localization. Why are we talking about localization for AMR or AGV or drones? What's the difference, Bryan?
Sure, that's a very interesting topic. So there are two terms over here, positioning and the localization. So positioning itself refers to determining the coordinates of the robot or device in a certain space or frame of reference. It's the process of measuring the exact location of the device relative to some known point or system. For example, in the GPS positioning, the coordinates are generally latitude, longitude, and altitude. And the frame of the reference is Earth. So in an industrial setting, for example, in a warehouse, this could mean the X, Y, Z coordinates within a particular facility. So localization, on the other hand, is the process of determining where a robot is within the environment relative to its surroundings. It is the ability of a robot to establish its own location and orientation within the environment, often in a relation with a map. So location goes beyond just coordinates. Positioning is just coordinate. Location, you also get to understand the position in the context of environments. So for example, with the AGV AMR robotics, they need to dynamically navigate through complex and changing environments. Knowing their exact coordinates or positioning is not enough. They also need to know their relationship to the surrounding environments. So not just the positioning, but also to understand what's what's nearby, where is the wall, and where to go next.
I see. That's pretty clear. So I guess IMUs must contribute a lot to localization. But what does an IMU do exactly on AGV or AMRs? Does an indoor AGV require IMU as well, Brian?
Sure. So IMU, actually, this product many years ago comes from the aviation products, like for the airplanes. So you go actually going, if you rotate like this, it's called a roll, and it goes up and down, it's pitch, and then you go left and right, that's the yaw. So in the past, these IMU, the high-end IMU, are used in the aerospace, in an aircraft or space rockets, and also it can be used in the drones. So which is critical to maintaining the stable flights. Now it comes to the AGV or AMR, the IMU can provide a lot of useful information. Firstly, the IMU itself has the accelerometer, gyroscope, magnetometer in there. And a lot of times people implement the algorithm, and then you can get the orientation. So for the orientation, as we just mentioned, the roll, pitch, and yaw, also the acceleration, angular velocity, which can be used to for the task like balancing these robots, like two-wheel robots, estimating the robot's position over time. The MU can also work with the other sensors like LiDAR or vision camera systems for applications like visual SLAM and LiDAR SLAM. So MU can augment the other sensors like LiDAR sensors, odometry sensors, camera sensors. The MU sensors itself has some specific features, like the update rate of the sensor is really high. Usually the sensor fusion data is up to 400 hertz. The raw data can be 2000 hertz. While the other sensor like a LiDAR is only at 10 hertz, camera could be 0.5 hertz. So these sensors can work with each other to compensate each other. And for example, the orientation of the sensor, the IMU sensor, can be used to correct the motion distortion from the LiDAR sensors.
That's very interesting. So obviously, IMU is a very precise sensor for AGV AMRs. But what kind of AGV AMRs or drones would really need an IMU? Can you share us a bit more about the use cases or their operational design domains, ODDs?
Sure. So for the AGV AMRs, as we know, for the AGVs, usually they have the predefined navigation map or the path. So for example, if you take a look at this picture on the lower left, that's the gray orange, one of the leading AGV company in the world. So they are actually using the Xsense MTI sensors inside. They are also using the camera for the QR code. In the factory, they have set up these facilities to implement a lot of QR code for navigation. But the orientation from the IMU sensors can be really useful between these QR codes. So we also call it dead reckoning, which means even if I don't have other sensors, the IMU could help to give you the positioning and the orientation. So recover from errors and understand the environment. And for the AMRs, as we mentioned previously, for these AMRs, they usually have their own ability to navigate and to change their directions until they arrive the target points. So for example, on the lower left, on the second one, that's the Chi-bot. Actually, that's one of our customers in China. That robot is used to navigate around the electricity generation facilities to replace the human predictive maintenance. So basically, they can just go around to check all the devices, equipment to see if it is good enough. And also we have Berkshire Grey, which is based on United States, and IM Robotics. Also on the lower right, we have this company from Taiwan, actually. So they have built these autonomous forklifts. So basically from there, you can see the LiDAR sensors, but also we have IMU sensor X and MTI installed there. As previously mentioned, the LiDAR sensors can work with the SLAM sensor vision technology. So when the LiDAR was scanning around, there could be some rotations and there could be some motion distortion. The image from the LiDAR or from the cameras could be distorted, and these are not really useful data. But if you combine the data from the IMU, then those information can be corrected, compensated. And IMU can also be used in the underwater robotics, also the autonomous robotics and aerial robotics to navigate in 3 dimensions. So this data from the IMU can be critical to maintain their stable and accurate movements.
Wow. So what you are saying is that no sensor is perfect, and very often they have to work with one another to compensate its deficiencies. So how can an IMU work with other type of sensors to achieve better results for AGV and AMRs, Bryan?
Exactly. Very good question. Yeah. So basically, there is a term called sensor fusion. So sensor fusion is a very wide term, but usually people are using algorithm like extended Kalman filter. So basically, the sensor fusion is the algorithm to combine the sensory data from different sources. So the idea is to take advantage of the strengths of each type of sensor and compensate their weakness. So on the right, you see this 2D LiDAR, which is usually used to prevent the collision. And the 3D LiDAR is used to do the mapping. So you get all the map of your surrounding environments. The 3D camera can be used to detect the positioning, and can be also to identify different objects. The IMU, in the other side, it can work together with other sensors we mentioned because it's high update rate. It can compensate the distortions of these image sensors, and it can also navigate by itself when the other sensor somehow is not functioning as well. So there can be different possibilities. For example, IMU can also work with the wear encoders, which is the wear speed sensors. As we understand, for those AGV and AMR products, usually they always have this sensor, and the odometry or the wear speed sensors can be useful to compute based on the rotation speed and the diameter of the wear, for example, to give you an absolute positioning. But the problem is that because of the wear slippery, and this wear could give you some error, for example, the wear slip, and there could be also a lot of weights. So it is also difficult to calibrate these kind of errors. So if we can combine the wear encoders with the IMU, so we have more information. For example, we understand when this sensor is not actually moving, or we can just do this algorithm to compensate with each other. So IMU with the visual sensors, as we mentioned, the cameras, LiDARs. On the right lower, we have a screenshot of this. This is from an essay from this link. So basically, you can see for these green ones, these IMU data are continuously outputting, which means it is really high update rates. But for the other sensors in between, maybe you only have very limited information in between. But in order to navigate around, you need to make sure all the images or all the point cloud data from the LiDAR sensors can have meaningful information about its orientation, which is actually from the IMU. So as a summary, the IMU can provide high rates motion information between the visual updates and help correct the motion distortion of the visual sensors. So combining different sensors on their strengths could be really, really useful.
Wow. Now I've got a much better understanding of what our customers are doing. Actually, many of the use cases you just mentioned are made by our customers around the world. So it's really a very complicated, very fascinating technology, but you really explained it very well. Now, I know that IMUs can fit into different use cases, different types of vehicles or carriers for different purposes. So there must be different form factors or different SKUs or different types of IMUs. Can you give us a general introduction of those different models, if I may?
Sure. So Accents, has was founded in 2000, so 23 years already. So the Accents' specialty is to build the IMU sensors. On the IMU sensors itself, we have the gyroscope, accelerometer, magnetometer. There's another term called a GNSS, INS, which is the global navigation system combined with the inertial navigation system. So basically, we combine these IMU chips together with the GNSS receivers. On top of that, we can also add the barometer or the camera sensors. So which could be the sensor on the right, which is the vision navigator. On top of that, we calibrate all these sensors and add sensor fusion algorithms. We can have different form facts. This is our software. So on the sensor itself, we actually categorize our sensors into different categories. So the IMU itself in our product line is actually gyroscope, accelerometer, magnetic field sensors, which give you the raw data. Well, on the VRU and AHS, we actually call it orientation sensor. Basically, on top of the raw data, we implemented the sensor fusion algorithm. The customers can also get a roll, pitch, yaw. And if we combine with the GNSS, we get a GNSS INS. So basically, with the fusion of all these sensor components, we provide the positioning, velocity, and GNSS time. In terms of the AGV or AMR, basically for the AMR, it could be indoor and outdoor. If it is outdoor, sometimes they really need the GNSS positioning data. So this product line could be used for. And there's also a trend that people are going into very, very accurate positioning, the RTK enabled. So real-time kinematics. The positioning of the position could reach centimeter level. And we also have the RTK-enabled visual and the navigation system. So we have the camera, we have the IMU, we have the GNSS all in one. So on the sides itself, so we have the small one, which is the MTI-1 series, which is really, really small. It's 12 by 12 millimeters. It could be really useful in the embedded system. People are using it in their embedded computers or in a camera or in a very small mapping device. One of the most popular product from us is the MTI 600 series, which is the plastic one or the metal one. So the MTI 600 itself has a very good pricing point, and the performance is also very well comparing to the industrial products. It has been widely used in the SLAM applications, as we mentioned, to work with the LiDAR sensors, camera sensors. And for the autonomous driving industry, we have this big one, MTI 680G, and the MTI G710. These two products have been referenced by a lot of autonomous driving communities. For example, AutoWell and NVIDIA's reference site. So this has been used in many autonomous driving datasets collections. So if you take a look at those leading research institutes, many of them are using our products for autonomous driving research and mapping, get all those digital maps and assets. So that's it from our products.
Thank you very much indeed, Bryan. We do learn an awful lot from Movella. And that concludes today's Embedded Talk. We will be producing more Embedded Talks like this one and to learn from our partners and users. We want to listen to you and see how Advantech can develop and improve the embedded hardware and software that really fit in your needs. For more information about Movella and Advantech's embedded solutions, check the link below and do let us know what you think about this topic. Thank you and goodbye.
Thank you. Bye bye.